Okay. I think we have Wednesday is the end of will be the end of naming, or at least the last day of lecture of naming. It's locked. Is the door?
Yeah, it's locked. Yeah.
Still? Okay, so questions? I do have one issue we need to go over, but number 59. Okay. Okay, 59. So how are we going to do that? So that has 1, 2, 3 different functional groups in it. Nope, that's not what we wanted to do. So how are we going to handle something like that? And I'm just going to handle it from scratch and try and match up the name. So when you have something like this with multiple functional groups in it, the first thing we need to know is, so who has the highest priority, what are the suffixes going to be, and what are the suffix, and then what are the order of the suffixes going to be. So this is where we go back to our chart here that I handed out last week, and hopefully you still have this, because we're going to need to use this to look at the groups and to determine who has priority, along with what those groups are called. So looking at this priority, there's a couple things on here that, and I'm going to redo this chart and probably give it to you, and then you can use that one on exams. But here's what's missing from this chart. Because somebody asked this morning, they said, well, if you gave us a name of like pentene oic acid, how do we know what the oic acid is? And we had talked about carbonyl functional groups last time, I believe, on Friday. And so the question is, with carbonyl functional groups, one side's carbon, and then what is the other side? And because that tells you whether it's an aldehyde or a carboxylic acid or an ester. So when you're looking at this chart, and they did something here, which I'll talk about in a minute. So these first two right here, these first two are C double bond O OH groups. So that's what a carboxylic acid group is. Okay. There are some of these we're not gonna worry about that much. I'm not concerned really about a sulfonic acid here. The anhydride, this one it has a C double bond O with another O and a C double bond O on the other side. So that's an anhydride. An ester looks like this. Okay, so this is an ester, this is a carboxylic anhydride, and these are carboxylic acids.
So then with the brackets?
I'll get to what the brackets mean in a minute, because they don't describe what the brackets mean or don't mean in the book as far as I can tell. So let's go down the list and I'll come back to whether it's got a bracket or not a bracket. So these two are esters. These two are what are called carboxylic acid chlorides, which we're not going to do much with right now. These two are amides. These are amides, C double bond O within the N on that side. these are nitriles, which just is a C triple bond N. And then these two are aldehydes, which are C double bond O's with the H's. And so aldehyde and amide and then ester, as I wrote there. Okay. And then carboxylic acid up here. And then once we get down to the last one's going to be a C double bond O with two alkyl groups on either side. That's going to be your ketone functional group. And then we're down with the rest of those. Those are just alcohols and amines, double bonds, triple bonds. So with these carbonyl groups, what I need to do is I need to adjust this chart to put the functional group name in there. And then also, what do the brackets mean? What do the brackets, bless you, not mean? Okay, so I'll give you a more full chart that you'll be able to use. So last time when I said, you know, you're going to have to learn all these different functional groups. One side carbon, what's the other side? If you have this chart, you don't necessarily need to know that. But if you do enough problems, hopefully it'll click as to what those functional groups are. Okay. So that's what's missing from this chart is the expansion. And just this COOH, that's a way of typing it out without having to draw out a full-blown structure. It's sort of the equivalent of putting a CH3 in brackets with a 2 around it, so you can just type out a structure as opposed to actually drawing it. Okay. So those are the different functional groups there that we'll be using. So if you see a C double bond OOH and you don't know what it is, then it'll be on this chart so you can correlate it. Yeah, it's a carboxylic acid. Okay, so first, does that make sense? So then what about the brackets? So the so let me just use the carbaldehyde as my reference point here. Okay. So the non-bracketed means that it is a ring. So that's when the group is attached to a cycloalkane ring. And when it's in brackets, it means that it's acyclic. No ring. Okay. And I have to set my bearings on. I know that when you have an aldehyde attached to a cyclohexane ring, it's called cyclohexane carbaldehyde. Yes, carbaldehyde. So I wouldn't have been able to figure that out either except I remember that fact. So I'll talk about rings. We can go over a ring carboxylic acid versus a non-ring, but that's what the bracket means. So when you don't have a bracket, you use the term carboxylic acid, and when you have that group attached to a ring, then it might have another name to it. So there's a column 1 here, which is what you call it if it's the highest priority, and then there's column 2 where it's if something else outweighs it. Now, I don't know what outweighs a carboxylic acid, so I'm not quite sure why that's there. Because we're not going to have anything that has higher precedence than a carboxylic acid, so we're not going to use that one. But if you did, that's what it would be. So that's kind of how this chart will help us make the name of the molecule. Okay, so the preferences as we go up, the higher priority means it gets preference in the numbering scheme, and it's last in the suffix list, is what that should mean, with all the caveats from last week. So, like I said, I'm going to redo that table, but I didn't have time to do it between this morning and this afternoon. All right, so we okay with that? All right. Now, let's go back to this problem. So what we need to do is we need to find the longest continuous carbon chain that contains as many of our priority functional groups as we can get. Okay, now, what is not a priority functional group? Alkoxys, halogens, and alkyl groups. There's no alkoxy here, so we don't have to worry about that, as there's no ether. So finding the longest chain that contains everything is going to look like this. Right. So that's the longest chain that contains the carbon with the carbon attached to a double bonded oxygen, the carbon-carbon double bond, and the carboxylic acid. Okay, so this is going to have 3 different functional groups in it that we have to deal with. Okay. Now, who has the highest priority of all 3? According to the chart. The carboxylic acid has the highest priority of all of them. The reason why it gets the priority, as best I can tell, and I think this is true, is because it has to be at the end of the chain. So whenever you have a carboxylic acid or an aldehyde or an ester, all those groups have to be at the end of the chain. And so that's why they're given higher priorities. And the carboxylic acid has been given number 1 priority on our chart. So that means number 1, number 2, number 3, number 4, 5, 6, and 7. So if nothing else, we know that this is going to be a hept, something. Okay. And if I look at my substituents, I have a CH3 group here. I have a CH3, CH, CH2, CH3. So this group right here is called what? What's that alkyl group? It's a sec-butyl group. Now, hopefully you would know that even when it's not on the screen as a sec-butyl group. And they put it in parentheses, which is not supposed to go in parentheses. So that is a sec-butyl group. Why is it a sec-butyl group? Because it's got 4 carbons, that makes it butyl, and the attachment point is a secondary carbon. If you don't count the longest chain, if you just look at the group, the attachment point is a secondary carbon. Okay, so that's a sec-butyl group, and of course we have a methyl group here. So, what is the numbering on the sec-butyl group? It's going to be a 4, and this is going to be a 6-methyl. So we've got a 4 sec-butyl group and a 6-methyl. As our substituents, who comes first?
I have a question.
Yeah.
Why shouldn't the sec-butyl?
Nope. Why shouldn't the sec-butyl group be what?
Why shouldn't it be in parentheses?
Because parentheses are reserved only for complex substituents who do not have a common name that has been accepted by IUPAC. So remember how we started with the list of things, the sec-butyl, tersh-butyl, isobutyl? Those are common names that have been accepted by IUPAC. So parentheses are reserved for any alkyl group that is not, complex alkyl group that is not one of those. And I don't know that we've done any of those in class, so we can do one of those afterwards.
Can you do a quick refresher on what it means to be a secondary?
So secondary means that if I just looked at that group, I would have a CH attached to a CH3, another CH3 attached to a CH2. So what it means is you are a carbon with two other carbons attached. So this is the butyl group where the attachment point is a secondary carbon. And notice I have to be specific about this. You don't look at the parent chain. So I'm ignoring the parent chain. So I'm only looking at the group not attached to the parent chain. Because the first thing you would say is, but with the parent chain attached, it has 3 carbons. I know, I'm covering up. I cannot cover up the parent chain.
So the 4 in front of the 4-sec butyl is because it's attached to the carbon 4?
Because it's attached to carbon 4 of the 7 carbon chain. And then this is 6 because it's attached to the 6th carbon. Okay. So I'm just putting the substituent numbers in because I need to alphabetize. And so now if I alphabetize, who comes first? The sec butyl is going to be alphabetized first. Why? Because whenever there's something hyphenated, you don't count it. So this is B and this is M. Okay, so in terms of the substituents, this is going to be a 4-sec butyl, 6-methyl, and then now what I need to do is now I need to look at the rest of the functional groups. So the carboxylic acid group is going to come at the end. Okay. So this is going to be a hept. Well, I got 2 things to name. I got 3 things to name. Number 1, I need to name the ketone. I need to name the alkene, and I need to name the carboxylic acid. Those are my 3 functional groups that I need to name. Okay. Now, in the name, whenever you have something like hept, if there was only single bonds in the longest chain, it would be a heptan. That's the default position, is the fact that when you say heptan, that means you've got a 7-carbon chain with no double bonds in it. If you have a 7-carbon chain that has a double or triple bond in it, that's when we go hept, number, and then either ENE or YNE. So in order to indicate that this is not just carbon-carbon chain, not single bonds, we would then have to put our number in and then ENE or YNE to indicate that we have an alkene or an alkyne. And then what comes after that is going to be the highest priority group. So at this point, we're going to have the highest priority suffix. So in the naming here, when you get to the final total number of carbons till the end of the name, you can really only have total number of carbons, whether it's a single, double, or triple bond, and then the final highest priority group at the absolute end. Okay. So this is going to be a hept. The double bond starts at 6, so this is going to be a hept ene, 6-ene. Now, whenever you try and put together an ene and something that starts with O, ol for alcohol, O8 for ester, oic for carboxylic acid, the convention is to drop the E. So instead of it being an enoic, the E and the O next to each other is not compatible. So this would be a hept 6-enoic acid. Now you might say, do we have to put the 1 in to indicate that the carboxylic acid is at carbon 1? And if you do, that's fine, as far as I'm concerned. But the convention is that the carboxylic acid or the aldehyde always have to be at the end of the chain. So that 1 is, it's understood that that group is number 1 always. So that's why we can say a hept 6-enoic acid, and we don't have to put the 1 in between the ene and the oic.
Why are butyl and hept capitalized?
Because I wrote them that way.
Okay.
They don't have to be.
Are you pretty lenient about like ENE if we like forget to drop the E?
I'm fine with that. There's a lot of little piddly stuff in here that's.
A hyphen, just so like we know.
So hyphens always come between numbers, and numbers and letters, and commas always come between numbers. So in general, there's hyphens always between the numbers and letters.
So should we always be looking out for if the substituent has like several carbons to indicate whether it's sec or tertiary or whatever? Because I feel like we don't do that very often.
Well, we do it when we're drawing the name. We do it when we're writing the common names that have been accepted as IUPAC names. And that's where this comes from. So you can either flat out memorize that this is a sec butyl group, or if you got stuck, you could say it has 4 total carbons, so it's a butyl. Which one is it? Well, is it straight? Then it's just butyl. No branches. Does it have an iso group? If it did, it would be isobutyl. Other than that, what's left over is, well, there's no neobutyl. There's only neopentyl. So after that, what kind of attachment point is it? Is it secondary? It's sec. If it's tertiary, it's tertiary. So that's where those are coming into play. That's really where they're coming into play, is as we're naming these. And again, I'm giving you kind of a systematic approach to the common names because there is. To remember, if you don't just remember that's a sec butyl group. So other than that, we don't have to really use it very much. So the only thing that's left over is, so what do I do about the carbon 5 that has a C double bond O? Okay. And there's probably an old numbering system out there that would put it in this line or in that sequence. But really, only 2 things are going to fit. Once you start putting together the longest chain, there's only going to be 2 things that go in that name, whether it's an alkane, alkene, or alkyne, and what the final highest substituent is. Okay. So I've got this group at 5. I've got a C double bond O. Attached to that C are 2 other C's, so it's a ketone. And so what is a ketone called when it is not the highest priority group? And if you're saying, I don't know, I can't remember, then that's when we go back to the chart and we look at that and we say, okay, here is our ketone. If it's the highest priority group, which means it's coming at the end, it would be an ONE. Otherwise, it becomes an oxo group. And all of these names in the second column are all treated as if they were alkyl groups, alkoxy groups, and halogens. So in other words, they move to the substituent list. is the way that works. So in this case, the reason that the book is calling this a 4-sex, 6-methyl, 5-oxo, and don't worry about the numbers, just all they did was they put it in the same thing, and you got to figure out what the numbering scheme is. They then move that ketone is now an oxo group, and so it gets moved to the alphabetized list of substituents, which fortunately comes after M. So now it would be a 5-oxo hept 6-enoic acid. So when we have 3 or more functional groups, well, when we can only fit the alkane, alkene, alkyne, and the final functional group in this final list. Everything else gets relegated to become a substituent just like everything else. And so then it gets alphabetized. So this is called an oxo group if it's a substituent. And I don't know how you I haven't tried to put these rules like in a nice step-by-step sort of flow chart here, although that's coming. Because all these different substituents is the final part of this chapter. Okay. So that would be the name of this, would be 4-sec-butyl, 6-methyl, 5-oxo, hept 6-enoic acid.
Should the oxo and the hept be together or separated by
They should be separate. They should be together. It's just I wrote one over here and I wrote one over there, so bring it together. I could probably do that, but I won't.
So on the list, there's a bunch of different like prefix if those precedents, like they all have the prefix of oxo. How would you know which one it is if you're just given a name and you had to draw it?
What's another one? Oh,
There's lots of them.
yeah, there's lots of oxos, but that's a good question. I don't think with aldehydes we ever use it. I don't think we use it with alkyl halide or acid chlorides, which we're not going to do. Esters, I'm not quite sure what the oxo. I don't even know why those are there. Because we're never going to use those. The only oxo is a ketone as a lower priority substituent. I put in Wednesday's folder some naming problems that I drew up, and I'll drop some more. But we'll do some on Wednesday as well, because it's kind of catching up with everything. But I just want to show you how to use that chart and what the format would be. This is kind of everything that you could have over here.
So we've kind of been doing naming where we were given a structure and we have to come up with a name.
Yeah.
Is it possible for you to give us problems that we would be given the name to come up with the structure, or not yet?
I could, and what happens normally is those are 95% correct. So if I give you a name and ask you to draw the structure, 95% of people get that right. I don't normally put those on the exam. I normally put the structure to naming. Because, and the thing is, you use that as a double check, right? If you want to make sure you wrote this name right, cover up the structure and go about writing the structure again, and do you get the same thing? Because if you forgot the oxo and then all of a sudden it's like, oh, I forgot the oxo. Or I numbered this wrong. Or I had a dimethyl and I only put one number in. Where does the other number, where's the other methyl go? So any kind of ambiguity, or if the structure's not correct, then the name most likely is not, you've drawn the wrong structure, or you've gotten the wrong name. What else? There was a question on did I do the ethers right? Did I show you that the naming of the ethers was right? Which I had to go, did I mess that up? No, I did not mess that up. I went and I looked at the blue book. And when I looked at the blue book, I found, what did I find? Let's see. Here's the blue book. So naming, so when you name ethers, one of the questions was, in the book they said, well, generally you start numbering at the carbon with the oxygen with number 1. That is generally not true. Now, when I looked at the blue book, the blue book is not very helpful. It gives you examples, but it doesn't give you a thorough listing of examples. So this is the example that you have to use I use to justify that, yeah, I did it right. If you look at this example right here, you have on this side of the oxygen, you have 2 carbons. On this side of the oxygen, you have 2 carbons. So we're tied. So we didn't talk about what would the tiebreaker be. The tiebreaker would be who has the most substituents. So in this case, the group on the right has more substituents by having the chlorine. So this would be the parent name on the right, and on the left would be the substituent. So this is going to be 2 carbon alkoxide or alkoxy group, so this is going to be ethoxy. And if I go to this as my parent chain, then the question is, I've got an ethoxy group here and a chloro here. How am I going to number it? I'm going to number it from the end closest to the first substituent, but I have 2 carbons, each having a substituent, so I'm tied. So now I'm going to number it from the end closest to the first alphabetized substituent, which in this case is the chloro. So that's why this is 1-chloro 2-ethoxy. The example, and I had to look in the book and like, what happened? And what happened is that the example they gave in the book where they made that statement looked like this. This was the one where they said generally you're going to start at number 1. The carbon number 1 is going to be attached to the oxygen. And this was the example they gave, which is exactly true. Because, again, here's my oxygen, here's my group on the left, here's my group on the right. 4 carbons win, so this becomes the parent chain. And so this group right here is my substituent, and that's going to be an ethoxy group. And then I'm going to number this chain from the end closest to the first substituent, which is this. So this would actually be 1-ethoxy butane. And so, yeah, on that side, you do start numbering at the carbon that's attached to the O. But that's because that's what you do with this molecule. Any other molecule, we just find the longest continuous carbon chain, and we treat this as if it was a bromo or methyl group. It doesn't get any priority unless it's at the end of the chain, or unless it has a higher alphabetization than the other groups. That's the only time it gets priority in the numbering scheme. So what I did on Friday is correct. And then I went back and checked problem 49, and the answer that I think I did in the video and circled was correct. So I don't know what they mean by generally, because it's generally not true. I'm coming up with a list of things that I'm gonna send them at some point and say, I could just delete the wrong stuff out of the book, but that's not my job. But to say, I think we need to think about these again. A definitive list? Like, I'll think about it. I just don't know how to put together a flow chart that would cover everything. That doesn't mean that you can't come up with your own flow chart. Because whatever you come up with is going to be specific for you and how you think. And as long as it gets you the right answer, I'm not going to mess with it. But on the other hand, and in doing that, that's part of the learning process, right? Is trying to figure out how do I organize it in here. So right now what you can see is a lot of these rules kind of follow. There's kind of the same rule, it just always falls back on things. So that was something that was pointed out, and I'm like, I hope I didn't mess this up, and whew, I didn't. What else? Because I can draw things, and I can have an agenda, but I'd much rather answer questions that you have. Problem 60. That's naming esters. Okay. All right, so you actually have to name 4 esters. Let's see, what's the most complicated of these? Well, there really is a complicated one. Let's take A. I think that's A. Make sure we've got like an isopropyl group on the left. That's not going to be called an isopropyl group, but just and then we've got another group on the right. Okay, so that's the correct. So that's the first one. So what would its name be? So for esters, and I think I did post a video on how to name esters, but I'll go back and hit the highlights here. Hit the highlights, I'm just good. I'll say it again. In order to name some of these things, you need to know how they're made. Because how they're made is how they get named. So for instance, an ester, the way we make esters traditionally is we take a carboxylic acid and we react it with an alcohol. Usually in the presence of an acid catalyst like sulfuric or phosphoric acid. We will learn this next semester. This is called Fischer Esterification. And what happens in this case is that we lose water in the process. So water is one of our products, and then we make the ester. Now I'm using the R prime and the R to indicate those could be 2 different alkyl groups. Now if I wanted to, I could use color here and show the idea that here is the group from the alcohol, is the red group. So when you look at an ester, this part came from the carboxylic acid, this part came from the alcohol. Okay? And so knowing that helps you in terms of naming it. Because when we name an ester, we're first of all going to name the alcohol part. Not the alcohol part itself, but the alkyl group that was attached to the alcohol that I use to make the ester. So in other words, this group, that alkyl group's name comes first in the name, because that was the alkyl group attached to the alcohol part of an ester. So that group would be what kind of alkyl group? Close. I don't. It's time we deal with that directly. I don't like that name, and IUPAC doesn't like that name anymore either. This book likes that name, but the book violates the IUPAC rules. Okay, we don't know. So how are we going to figure this out? It is isobutyl. 4 carbons total, so that makes it a butyl group. Is it a straight chained butyl? No, it's branched. Does it have an iso group? Yes. This is the iso group right here. The CH3, CH, CH3, so this is an isobutyl group. So the name of this is going to be isobutyl something. But that first word in the name is always the part that came from the alcohol. So now we go to the carboxylic acid part, and I'm going to name it like I would name a carboxylic acid. So automatically the carbonyl group at the end of the chain is number 1. Find the longest chain that contains any other functional groups. There are none. So I'm just going to go 1, 2, 3, and it doesn't matter whether I go 1, 2, 3 up or 1, 2, 3 down. I'm still going to have a methyl group at carbon 2. Okay, so this is going to be isobutyl 2-methyl. This is a 3-carbon chain on my carboxylic acid part. So that means I'm going to have prop. Are there any, is it all single bonds or is it a double or a triple bond? It's, the longest chain is all single bonds, so that means it's going to be a prop-an. And now if this was an acid, it would be propanoic acid, but since this is an ester, the final suffix is O8. So this becomes a 2-methylpropan O8. So the OATE signifies ester. The propan indicates that it's a 3-carbon chain on the carboxylic acid side with all single bonds, and the 2-methyl indicates that there's a methyl group at carbon 2. So this would be isobutyl 2-methylpropanoate.
Can we go over one more time where the propan came from?
So the propan came from the fact that now I'm going to basically look at this part of the molecule, and I'm going to name it as if it was a carboxylic acid, but then I'm going to change the suffix at the end. So knowing it's a carboxylic acid then, or an ester, I have to start numbering at the carbonyl. And now I'm going to find the longest chain, which in this case the longest chain was 3 carbons. So that's where the propan comes from, the longest chain, and then the 2-methyl is the group that's attached. So the propan comes from the fact that it's a 3-carbon chain with nothing but carbon-carbon single bonds. So esters are named alcohol part first, carboxylic acid part second, and instead of being an oic acid, it becomes an OATE. Does that make sense?
So we can call the molecule on the left of iso because it's a part of the.
Right, it's a different set of rules. It's a different set of rules. We have to use the IUPAC name for the left-hand side. Now we are also using the IUPAC name for the right-hand side, because what IUPAC has now said is that this group is an isobutyl group. That's its IUPAC name. But the one on the left has to be named by IUPAC, which means longest chain, etc. Okay. Now, let's deal with this. Let's take a couple minutes and deal with this silliness of 2-methyl-ethyl. No, sorry. That would be a 2-methyl-propyl group. Okay. So there was a time when 2-methyl-propyl, well, let me just say, here's an isopropyl group. I'll do it against my better judgment. I'll put the isopropyl group here. Okay. Now, some people called this an isopropyl group. Some people said, I want to use the IUPAC name for naming complex substituents. And a complex substituent is just something that doesn't have an IUPAC common name, or a common name accepted, which IUPAC has changed now to say this is isobutyl, not anything else. But back in the day, what they would say is, if you had a complex substituent like this, what you would do is you would always number at the attachment point. That automatically becomes carbon number 1. Then you would number, or then you would find the longest chain. Starting at the attachment point, that automatically has to be carbon number 1. So we would go 1, 2, 3. So that would make this a propyl group. Okay, this is a substituent, so it's not a propane, it's a propyl group. And then what's attached to that carbon 2? A methyl, so this would be a 2-methyl propyl group. Was a commonly accepted IUPAC name up until IUPAC said, no, we cannot have some people calling this an isopropyl group and some people calling this a 2-methyl propyl group. That defeats the purpose of IUPAC, which is to come up with one and only one name. So they said, you know what? We're not going to have people, we're not going to break people of the 2-methyl or of the isopropyl, so we'll just accept that and say, or isobutyl. This is an isobutyl group now. No more of that. Except that when you have a 2-methyl propyl group, and you're going to put it in the listing of alphabetized substituents, you can't get the 2-methyl confused with the number that's going to come in front of the 2-methyl, because this is going to be like at carbon 5 on a chain. So you have to put this in parentheses to indicate that it is now a complex substituent with an IUPAC name, which gets back to the first question of why am I violently opposed to putting sec-butyl in parentheses. It's because these go in parentheses, not the sec-butyl group. And let's say this was attached to carbon 5. You would have like a 5-2-methyl propyl, but the 2-methyl propyl is in parentheses, so I know that group is there. Then the other thing would be, how do you alphabetize this? It doesn't matter what the first letter is, that's what you alphabetize on. So this gets to the anomaly of, what if I had a 1,1-dimethyl ethyl group in parentheses? The first letter is D, but you don't alphabetize D. You do if it's in parentheses. So a 1,1-dimethyl ethyl group is a tertiary-butyl group. We made the mistake of using a book one year that didn't have common names. It only had IUPAC names in brackets. And so I had to remember the 1,1-dimethyl ethyl group was a tertiary-butyl group. So they've gone the other way and just outlawed these kinds of things. Now, 30 seconds. You might say, Or fine. If this group was a substituent, there is no common name for this group. There is no IUPAC accepted common name for this group. So this would be a complex substituent where you would have to automatically start numbering at 1, 2, and 3. And so this would actually be a 2-chloro, 2-methyl-propyl group in parentheses. And so these are the kind of groups that go in parentheses, the ones that don't have a common name and are complex. But the key thing about this is, and the rules for this are at the bottom of the list, my handwritten sheet from a couple weeks ago on all the different alkyl groups that you had to learn. At the bottom, it actually goes through the steps here. The number one thing you do is you have to start numbering at the attachment point. You don't have to find the longest chain. You have to start with that group that's attached, that carbon that's attached, then find the longest chain. And so this is an example of a complex substituent. And so IUPAC, the book uses these terms. Those terms, they're falling into the trap that I fell into years ago, which is you allow both sets of names to be used. Those two names have two different alphabetizations. And so you can have, depending on how many of these stupid groups you have, if you have 3 of these, that means you have like 6 different names that could be correct. And then at some point IUPAC said, no, we're not going to break people of common names, we'll accept them. And from now on, this is what you have to use. And then what does the book do? It puts in parentheses the obsolete names. Okay? So that's where all of this comes from. Okay, for Wednesday, I think it's complex. It's names with all these groups in them. Take a look at that. If you have any questions about naming problems, send me an email, put them up on Piazza, and I will go through and answer whatever you give me.